So p of x equals to, let's say, 3x to the power 5 plus 4x to the power of, let's say you've got square root. Then that's not a polynomial. This whole thing is not a polynomial. And if you have like 4 over x squared, that's also not a polynomial, because this is the same thing as 3x5 plus 4x minus 2, isn't it?
Yeah.
Do you know this power relationship?
Yeah.
So that's not a polynomial, okay? So it must always be x to the power of some positive integer or 0. So if you have like 4x3, 2x, that's fine, that's 1 here, right? And then 6, that means if you just have a constant, that means it's just x to the power of 0 there next to it, because anything to the power of 0 is 1.
Yeah.
Right?
Yeah.
So that's an example of polynomial. So recognize features for graph of this, for that. Okay, so this over here is a polynomial of, we say polynomial of degree 5. You just read the highest power, okay?
Yeah.
And the coefficient is 3, 4, 2, and 6. These are the coefficients. Usually we call this guy the constant. And these guys are coefficients, okay?
Yeah.
Does that make sense?
Yeah.
Now, so that part is done. Identify coefficients and degree of polynomial. That's covered. Now, just briefly, when you have, we just know what, if you have y equals to x, what does that look like? It's just a straight line, isn't it?
Yeah.
Through the origin. So that's the graph. And if you have y equals to x squared, what does that look like? It's a parabola. So we covered that already. And what about negative? So y equals to negative x squared. That's just the other way around, isn't it?
Yeah.
The mirror image. Okay, and when you have y equals to x to the power of 3, what does that look like? It looks like this. When you have y equals to negative x cubed, and then it's just the other way around like this.
Yeah.
And what about y equals to x to the power 4? It looks pretty much the same as this one, but it's actually flatter at the bottom here, like this. Okay?
Yeah.
And negative of x to the power 4, y equals to negative x to the power 4 looks like that. And y equals to x to the power 5 will look pretty much the same as the cubic one, but it's flatter. Okay. Yeah, it's very difficult to draw this. I'll just do my best. Like that. And like that, okay? And it'll be just the other way around like this. So that's y equals to x to the power negative x to the power 5, so on and so forth, okay?
Yeah.
Now, how do we draw y equals to x to the power of negative 1? That's the same as 1 over x, isn't it?
Yeah.
So that's equal to, it's a hyperbolic function. So it actually looks like this and this over here. So that's y equals to 1 over x. And if you have y equals to negative 1 over x, it's just the other way around. It's on this side and this side. Okay?
Yeah.
So this one over here includes both this one and this one, okay?
Yeah.
And that one here includes that one and that one. Have you seen those graphs before?
Yeah.
Okay, that's very good. And when you have y equals to square root of x, then it just looks like this. Now there's a bit of variety for this equation. So if you have, you may have y equals to root of x, negative root of x, root of negative x, and the negative root of negative x, okay?
Yeah.
So there are 4 of those. So I'm going to call this one 1, 2, 3, 4, okay?
Yeah.
Now, this is number 1. And I'm going to do this. I'm going to do that. And also this one, okay? Now, this is number 1. Number 2 is which one? Which color?
Is it green?
The green, okay? So green is number 4, actually. That one. So when you did the graph translation, if you have f of x equals whatever, and then you have this effect here, have you gone through the graph translation?
I don't think so.
Okay. So when you take the negative sign on the outside of this whole function, you see that's the original thing, right?
Yeah.
So this is taking the negative sign on the outside, do you agree? This is taking the negative sign inside, true?
Yeah.
So we see that there's a bit of analogy between that one. So that's number 3, and that's a bit like number 2, isn't it?
Yeah.
That's taking the negative sign on the outside, which is that one there. And this is taking the negative sign on the inside, like this one here. True?
Yeah.
And this is a bit of both,
Yeah.
that one and that one, right? So that's why the number 4 is actually over here. The reason is, if you take the negative sign on the outside, I should have maybe changed the color of them. So that's blue. That's blue. And that's red. You get the reason why, right?
Yeah.
It might be a little bit complicated, but if you take the negative sign inside, you have to flip around the y-axis, okay? So you get this one. So that's number 3. If you take the negative sign on the outside, you just have to make everything negative, so it just goes to the bottom. So that's 2, okay? So all of these techniques will be used. So what you're going to learn this whole term is going to be about graphs, pretty much.
Okay.
Graphs, different types of graphs. You'll learn, have you done circle graph yet?
Not yet, no.
Okay, you'll learn about circles, you'll learn about hyperbolas, you'll learn about parabolas, you'll learn about cubic functions, you'll learn about trigonometric functions, sine graph, cosine graph, you'll learn about logarithmic graphs, you'll learn about, all sorts of graphs, the square root function, all of these. And how they move, like move to the right, up, down, all of that stuff, how they reflect, like this, so it's all about understanding how to graph them, okay? So pretty simple topic, an essential topic, if you want to move on to, differential calculus eventually. So this part is covered. So we went through recognized features of this graph, y equals to x to the power of n, and n for any number of integers like 1, 2, 3, -1, and half, including shapes and behavior as x goes to infinity and negative infinity. So what happens as x goes to infinity? It just stretches, goes up, and this is going down, this is going up, up, down, down. Pretty straightforward. When it comes to hyperbolic functions, it approaches 0, okay? It approaches this x-axis. This approaches that as well, okay? And that goes up to infinity. And there's something called asymptote. Have you heard of asymptote?
Yeah.
So when you have a hyperbolic function, this vertical line there is called an asymptote. An asymptote is something that the curve, I would say, if it's a vertical asymptote, then the curve doesn't cross over. Something that so vertical asymptote is something that the curve cannot cross. Okay, but horizontal asymptote. So let's take a look at this one. So this one is horizontal asymptote, isn't it, over here?
Yeah.
And horizontal asymptote is something the graph approaches, okay? I would phrase it this way, as x goes to infinity or negative infinity, okay?
Yeah.
So that's that point done. Okay. Now, I'm just gonna put a tick mark there. So expand quadratic and cubic polynomials from factors. Okay. So if you got to x minus 2, x minus 3, you know how to expand it out, right?
Yeah.
So that's pretty straightforward. So you get negative 5x plus 6. Mm-hmm. If you have, just try this one maybe. Expand this one out, please.
Okay.
Yep, just do it yourself on a piece of paper, and you can just send me a photo. So, you know how when you learned parabolars, you learned about 3 different forms, right? One is the general form, ax squared plus bx plus c, right?
Yeah.
And the second form is the x-intercept form, like that.
Yeah.
And the one is the vertex form. So each has its own advantage and disadvantage. You just need 3 things to figure it out. So the vertex and the, what is it? The x-intercepts, and that's the y-axis. This is the y-intercept, right?
Yeah.
So in this case, the y-intercept is given by that one. The x-intercepts are given by these ones. And the vertex is given by h and k, true?
Yeah.
So each form has its own advantage, as you can see.
Mm-hmm.
So how do you work out the what is it? The y-intercept, x-intercepts, and the vertex. Now, just gonna make this table for you. Maybe you already know this stuff, but it's good revision to see this in one nice table. All right. So draw another line there. So you just need to read C. C is the y-intercept. Y-intercept is a y, so it's 0 and c. Okay.
Yeah.
Now x-intercepts are alpha and 0, and then a beta 0. Just read them off from this form, and the vertex is just a hk. That's it, right?
Yeah.
Now, if you want to figure out the vertex, you just need to take, all right, the x value is take the average of the 2 intercepts, just take the average between this and this, then you get this value, okay?
Yeah.
So this will be x equals to alpha plus beta over 2. And y value would be just plug in this x value into this original. So you just plug that in. Hold on, it's frozen. Plug in. That's how you do it. And what about y-intercept? Just to plug in x equals 0. Then it'll be, maybe the writing is a bit too small, but I think you can see this, right?
Yeah.
Then you get y equals to a alpha beta, because it'll be 0, 0 there. So it'll be a times by alpha times by beta. The negative cancel out. And if you want to find the x-intercept for this form here, then you got to use the quadratic formula, negative b plus and minus square root of the delta. Delta, remember delta is b squared minus 4ac. Have you gone through that as well?
Yeah.
Yep, over 2a. So you know this formula, right? And the vertex is given by x is equal to negative b over 2a, and the y is plug in. So the reason for that is because you know how the x-intercepts are given by negative b over plus and minus square root of the b squared minus 4ac over 2a.
Yeah.
So your alpha is minus b, maybe plus square root over 2a. Your beta is negative b minus square root over 2a, true?
Yeah.
So if you take halfway between those two, you see one of them is like negative b plus root on 2a. The other one is negative b minus root on 2a. So what should be this middle thing? It'll be just minus b over 2a, isn't it?
Yeah.
Because that's plus root and this is minus root. So in the middle, it must be nothing, right?
Yeah.
So that's why the vertex can be found through that formula there. You see, that formula is just from there, isn't it?
Yeah.
Negative b over 2a. That's the vertex. And then you just plug that into the original equation. So to plug this x value in here, then you get this one. And if you want to find the x-intercept with this one, then you just have to let y equal 0 and solve for x. So this is a bit complicated. And y-intercept, just plug in x equals 0. Okay, and then solve for y. So that's the summary of quadratic parabolars. Do you need a little bit of example for this, or are you pretty good with this?
I think I'm pretty good with that.
Okay. So you already know this method. Now, so I'm not going to go through that then. But does that graph, does that table help?
Yeah.
To summarize everything?
Yeah.
Yeah, that's the summary of quadratic equation in just one table. Now, when you have cubic functions, you also have something similar. Y equals to ax cubed plus bx squared plus cx plus d. So that's the general form.
Yeah.
And then you have your factorized form, and y equals a x minus alpha, x minus beta, and then x minus gamma. And the last form is the vertex form, x minus h cubed plus k. Okay, so the shapes of cubic functions are diverse. So for parabolars, they only have this shape, right? Or that shape. But for cubic function, for very simple, if it's factorized. Okay, so let me just tell you something. So it could look like this, or with see how that's just going through one. So this is x here. So it could go through just one point like that and have that sort of shape, or it could be, doesn't have to be going through the x-intercept, x-axis at the stationary point there. It could look like this as well. Okay.
Yeah.
So I would say this shape, this chair shape, is a basic cubic function, the shape of basic cubic function. But it could also look with ups and downs like this. Okay?
Yeah.
And this one is alpha. You can say that's beta. That's gamma. Okay? Or it could be the other way around. Alpha, beta, gamma, doesn't matter. Okay?
Mm-hmm.
So I would say that this one looks more like this when it's factorized. You see how you have all these factors and they guarantee 3 x-intercepts, you see?
Yeah.
Yeah, so that's why the second formula looks more like this one over here, and this one over here is guaranteed to look something like this. Okay.
Yeah.
So it's never going to look like that. Okay.
Yeah.
Now the general one can be both. Okay. And of course, going from form number 1 to 2, the process of going from 1 to 2 is what? This is known as factorization, true?
Yeah.
And going from 2 to 1 is expansion. And if you go from 1 to 3, that's completion of cube. And that's not easy. I don't think we need to cover that. And of course, 3 to 1 is expansion, true?
Yeah.
In a similar way, do you know how to go from the general form to the vertex form? That's completion of square, isn't it?
Yeah.
Have you learned that as well?
Yeah, we did that.
Yeah, so no problem. So I'm not going to go back to that. Anyway, so what we'll learn is learn to factorize from 1 to 2. That's what we're going to learn. And also learn to plot 2 and 3. So we're not going to learn to plot 1 because that's hard. But once it's in the shape of 2 and 3, it's pretty easy to plot, okay?
Yeah.
Now, so we'll talk about B first, okay?
Yeah.
So if you look at the course outline here, recognize features of this graph, which is the vertex form, right?
Yeah.
And this graph, which is the factorized form. So including shapes, intercepts, and behavior. So this is our B. Factorize cubic polynomials in cases where linear factor is easy to obtain. So that's A. Okay, so we'll talk about those two now. So if you have, it's very simple. If you have y equals to 3 x minus 5 cubed plus 6, then all you have to do is recognize the vertex. It's not really the vertex, I would say. It's the, so number 3 is, because for quadratic, it's a vertex, but for cubic function, what do you call that point? That's called inflection point, right?
Yeah.
Inflection point. Well, I'm just going to stick to the word vertex form, okay? Just for sake of simplicity. You can call it inflection point, doesn't matter, okay? We're just learning the technique. The exact terminology can fix that later. So what's the vertex here for this one?
3.
It's 5, 6, isn't it?
Yeah.
Yeah, 5, 6. So 5, 6 somewhere there. So I'm going to say that's 5. I'm going to say that's 6. You don't have to do this, okay? Don't do that anymore. When you have to plot this by yourself, okay, it doesn't have to be in scale, okay?
Yeah.
So unless you provide a graph paper, you don't have to do 1, 2, 3, 4, 5. Never do that. That's unnecessary.
Okay.
You can even say like, that's 5 there and that's 6 there, right?
Yeah.
It doesn't matter. You can still do that. It just means that the x-axis and the y-axis do not have the same scale. Have you ever used like the GeoGebra or Desmos?
Yeah.
So in it, we can say even something like that if you do x squared, it looks very narrow, but if I change the x-axis, y-axis, so if I change the x-axis to negative, let's say 5, and this is also negative 5, let's say. Oh, sorry, positive 5. You see how the graph became very broad?
Yeah.
And you see how distance from there to there is 2, but distance from there to there is 2?
Yeah.
They don't look the same, true?
No.
You can do that. Doesn't matter. Okay? Doesn't have to be in scale. So I'm going to practice what I've just preached. So I'm going to say that's 5 there, that's 6 there, okay? And you have to recognize what shape this is. This is going to be either that or that, okay?
Yeah.
So that occurs when this A here is positive, when A here is negative, okay?
Yeah.
So this is going to look like this, okay?
Yeah.
Now, but before you draw this like that, what that means is that it's going to go through what you've just drawn there is it's going to go through positive x-intercept and negative y-intercept, right?
Yeah.
But we don't know that. It could go sort of like this. It could be actually going like that.
Yeah.
Who knows? So it's not wise to draw this end first. It's definitely going to go up this way, so you can draw that bit if you want. But I'm just going to figure out what my y-intercepts are, okay?
Yeah.
So y-intercept is pretty simple. Just plug in x equals 0 there, right?
Yeah.
Negative 5 to the power of 3 plus 6 there. So this will be negative 125 times by 3. So that's equal to 375, I guess, plus 6. So it's a pretty negative number. Is that right? Did I do my math correct? I'm going to pull up my calculator. So 5 by 5 by 5 times by 3, that's 375. That's right. So but negative. And then you add that and you get this one. So that means the y-intercept is negative. So what that means is it's going to go through that point there instead of that point there, right?
Yeah.
And that means it'll naturally have a positive x-intercept, true?
Yeah.
In these two, it begs for this one over here. And of course, you can work that out by plugging y equals 0. So 0 equals to 3, x minus 5 to the power of 3, plus 6. Can you solve this and figure out this point over here, please?
Okay.
So I'll give that to you as an exercise right now. So that value is negative 369, which is that value there. Yep, give it a go, and you can tell me the answer or send me a photo, doesn't matter. Yeah, so it'll look something like this. Negative 6 equals to 3, bracket x minus 5 to the power of 3. And you'll have to divide by 3, right? So it'll be negative 6 over 3 equals to x minus 5 to the power of 3. And then you take cubic root of that, so cubic root of 2, negative 2 by the way, equals to x minus 5. So x will be 5 plus cubic root of negative 2, but that's the same as, just having put the negative sign outside because it's cubic. The negative sign survives. So it'll look like that. That's why it's a little bit less.
Yeah.
Right? So it's a 5 minus cubic root of 2. So that'll be 3.74. 3.74. True?
Yeah.
Yeah. So that's the answer to this graph over here. Okay. Now, let's move on to the next slide. I'm going to save this as a file. So if you have y equals 2, let's say minus 3, and then 2x minus 1 to the power of 3 plus 1, okay? How do we draw this one? All right. So let's figure out the vertex first, or the inflection point. So it'll be something and 1, right?
Yeah.
Because of that 1 there. We have the y value of the vertex to be 1. Can you work out the x value of the inflection point, please?
Okay.
So you can see that there's a -1 there, but there's also 2 here, right?
Yeah.
So do you know how to work out the vertex in this case? It'll have to be whatever this value, the value of x that makes this thing 0. Understand?
Yeah.
So 2x minus 1, let that equal 0. So the reason why, if you have a parabola like this, then your vertex is 2, 5, isn't it?
Yeah.
The reason why we take this value as it is and this value, we just take the opposite of that, maybe that's how you learned it, but that's not really the correct way of doing it, you know? So the value that makes this whole thing 0, if you let that equal 0, then you get x equals to 2, right?
Yeah.
That's why you get 2 for your vertex. Understand?
Yeah.
And if you have this on the y on the outside, other side, and if you actually move it to the other side, you get y minus 5. What value of y makes this one 0? Y must be 5, true? To make this value 0. That's why it must be 5 there. But if you actually move it to the other side, it appears as though you can just take that value as it is, right?
Yeah.
So if you have y equals to bracket 2x minus 1 squared plus 5, let's say, then the vertex is half and 5. Because if you plug in half there, it'll be 1 minus 1, and that'll make it, 0.
Yeah.
So that parabola will look like this, half and 5. So half and 5 is over here, and it'll look like that, okay? That's parabola. So in a similar way, it's 1 and half, right? Half and 1. So half and 1, so just do it like that. And you see how that's negative?
Yeah.
So just got to go the other way like this. So in this case, you can draw. It doesn't matter which direction you draw it. And, it could look like that. Doesn't matter because it's guaranteed because of the direction. It's only when you approach this region that it gets complicated, because if it's going through that, it could go like this or go like that. You just don't know if it's positive, negative, or negative, positive, right?
Yeah.
But if it's heading toward that direction, we already know it's going to go through positive intercept and positive intercept. So you just don't have to worry about you can just draw it straight away and then calculate those points later.
Yeah.
So you got, if you plug in 0 there, you get y equals to -3, and then plug in 0 there, you get -1 to the power of 3 plus 1. So that's equal 3 plus 1, so that's equal 4. So that point there is 4. And plug in, to find that point, you just have to do 0 equals to -3, 2x minus 1 to the power of 3 there, plus 1. Move that to the other side. So you get this. And then move 3 to the other side. So you get 2x minus 1 to the power of 3, 1 and 3. And then you take cubic root, right?
Yeah.
That's equal to 2x minus 1. And then move 1 to the other side. So you get 2x equals to 1 plus cubic root of 1 over 3. And therefore x is equal to just 1 plus. It's always, figuring out the x-intercept is always a bit more complicated. So you get something like that in exact form. Okay. And definitely it agrees because that value is half. So this value must be a little bit away from half, right?
Yeah.
So that's half. As you can see, this is half plus that, right?
Yeah.
Half plus cubic root of 1 over 3 over 2. Okay.
Yeah.
And as you can see, this value was 1, but 4, that's way higher than 1. So that agrees with them. Okay. So that's brief introduction to how to graph. So we were talking about how to graph, how to plot this stuff, right?
Yeah.
And also, we haven't talked about how to plot this stuff yet. This is easier. So we'll move on to that soon. We've got 3 minutes, so we'll just actually we've got like 5 minutes. So yeah, we'll talk about one more example of this and move on to this stuff. Okay.
Okay.
If you have y equals to -3 and then 5 minus 4x to the power of 3 minus 4, let's say, then you can figure out the vertex as -4. Pretty simple, right? Is that one?
Yeah.
And then you just got to figure out what makes that bit 0.
Yeah.
That's equal to 5 minus 4x equals 0, and then you just solve this, and you get 5 on 4 equals x, right?
Yeah.
Is that going too fast, or?
A bit.
A bit, okay. So we just let that equal 0, then you get that, and then you just move this one to the other side, and you get what? Positive 4x, and divide both sides by 4, then you get 5 on 4, right?
Yeah.
Equal everything?
Yeah.
So that's 5 on 4 here. So that's the vertex, so we're ready to draw. So it is 5 on 4, so it's a little over 1, right?
Yeah.
So just go for, that's 5 on 4. You don't have to draw somewhere they're very close, okay? If this point vertex is a dot, and that's a very important feature of this graph, right? So
Yeah.
it's better to draw somewhere, over there rather than over here or over here,
Yeah.
Too close to the vertex, the y-axis or x-axis, then you end up with a very ugly looking graph, okay?
Yeah.
So whatever you want. So just take point somewhere away from the origin, okay? So that's -4, that's 5 and 4, so that's all fine. That's all good. And just have to figure out the orientation. So you just figure out, number 1, you have to figure out the vertex. Number 2, you got to figure out the orientation, whether it's that way or that way. And number 3, you got to figure out the intercepts. Okay. So, I want you to have a look at this one. So it's negative here, isn't it?
Yeah.
So you may think that it's going to be this one.
Yeah.
Rather than this one. But there's another negative sign there in front of x, and that's the power of 3. So in fact, if you know a little bit of algebra, this is actually the same as 3, and then 4x minus 5. So switch this one and this one to the power of 3 minus 4. It's exactly the same thing. These two are the same. And this gives you still 5 on 4 and -4.
Yeah.
Okay? So the direction is actually this one.
Yeah.
Just got to figure out this one and this one, okay? So I'll leave it to you as homework to figure out those points. So I'll send it to you now as a photo. So I've just done that. Now when it comes to plotting y equals to a x minus alpha, this is really easy stuff. Because they already give you the x-intercepts, right?
Yeah.
I just need to know a few things when you're plotting something like this. Number 1, you need to know the nature of those x-intercepts. So if it's x minus alpha to the power 1, and let's say that's alpha, the graph will pass through it like this, or like this. Okay?
Yeah.
Just go through it. If it's an x minus alpha square, all power 4, all power 6, then what's going to happen is it's going to still, that's the x-intercept there, but it'll be x-intercept with bouncing off behavior. So that's still x-intercept. It just touches that point, but it'll bounce off of it.
Yeah.
But if it's coming from below, then it'll bounce off like that.
Yeah.
All right. Now, if it is an x minus alpha to the power of 3, 5, 7, then it's going to go through alpha, but in a cubic manner. We've seen this before, right? So it'll go through it, but with a flat stationary point there. So it'll go through like that. If it's coming from above, then it'll go through like this. Does that make sense to you?
Yeah.
Now, so I'm going to give you some question. So we can go beyond the cubic function. If you have 2 and then x minus 1, x minus 2 square, and then x minus 2 plus 5 to the power of, let's say, 3. Besides this stuff here, you need to know, number 2, the orientation. So we'll talk about that right now. So for quadratic, it's like that or like that, right?
Yeah.
For cubic, it's like that if it's positive. If overall the sign is positive, we'll talk about that later. So this is when A is positive. This is when A is
Negative.
Negative, that's right. Just give me a second. Just need to talk. All right. So for cubic, it's going to go like this. That's the direction. So it's up, down, down, up. For quartic, if it's power 4, then it'll look like this, or like this, so on and so forth. If it's the power 5, it's up there, down there, up there, down there. So it'll be 1, 2, 3, 4, 5. So maximum going through 3 points there, 4 points there, 5 points there, right?
Yeah.
So this pattern continues. So 1, 2, 3, 4, 5. Okay. Now, when you expand it all, I see how there's no negative sign in front of x.
Yeah.
So when you expand it all out, eventually you get 2x to the power of 6. Because there's 2 there, 3 there, 1 there. So total order is 6. And it's 2 at the front, right? So if you expand it out, you get a bunch of stuff. So how do we draw this stuff? Just need to draw the x-axis, y-axis. That's 1, 2, negative 5. So 1, 2, negative 5. Understand?
Yeah.
There's power of 6, so it'll be like that. Okay, and it's positive, so that's why it's up, up, just like the cubic one over the quartic one over here. So we didn't draw the power of 6. You see that when it's even power, then it's both facing up or both facing down, right? If it's odd power, then it's down, up, up, down. If it's even power, up, up, down, down, right?
Yeah.
So it'll be like this one here, but with possibly more points, you know?
Yeah.
So just need to know that it's going to be facing that way and that way, okay?
Yeah.
Now, because it's cubic there, you see that? Cubic?
Yeah.
So it'll come down, and then we'll just pass through in this cubic manner, as described over here. So we'll do that. And when it comes to passing through 1, it has to go through 1, but it's 1 there, so it'll just go through it.
Yeah.
So it'll eventually come down and then go through it, like that. And then because it's a square, it'll bounce off of it, like that. And there you go. That's the graph of it, okay?
Yeah.
It's pretty simple, right?
Yeah.
So if you know this technique and this technique, and you can even draw, you can draw a cubic function that's pretty simple. You know, if you have y equals to -3, x minus 1, x minus 2, and then 2x plus 5, then how do you draw this thing? It's 1, 2, and then that's -5 and 2.
Yeah.
-5 and 2, that's 1 and 2. -5 and 2 is actually bit further away. And all you have to do, because that's negative, so it's that shape, right?
Yeah.
So we'll just go through that, and that, and that. That's it. And how do you figure out this point? Well, just plug in 0, 0, 0. then -3, -1, -2, 5. So that's equal to 10 times 3, which is -30. There are 3 negative signs, so negative sign survives.
Yeah.
This will be -30. So today, so that's it for today.
Yeah.